That one you can't do at home, but the next one you can. Watch. Patrick, don't leave. Patrick and I are going to do this experiment. If you watch carefully, you can all do this.
Okay.
This is an ordinary plastic bag. Patrick, hold the plastic bag open with two hands. And I have here an ordinary pitcher of water, and I'm going to pour some water into that bag. Now, if you watch carefully, you should be able to do this without a problem. Now, Patrick, hold on to that bag. I'll take the bag. Thank you. Patrick, look straight ahead. Don't look up. Don't look sideways. Just look straight ahead. Don't anyone tell Patrick what we're going to do. Ready?
Other than
Not a drop of water. That is, you can do this at home. Don't do it over the kitchen sink. Do it over the kitchen sink, not over your parents' dining room table. This is a plastic bag. It's an ordinary plastic bag. And scientists invented the plastic bag not that long ago. They invented it because paper bags used to tear and leak. Does anyone here know where plastic comes from? This is good science. I will tell you. It comes from oil. Oil under the Earth's surface. They take it and they turn it into plastic. If you try this at home, the only thing you have to remember is use ordinary water. It can be any plastic bag at all, like a Ziploc bag. But once you start to push the pencil through, you can't stop. You have to go all the way. And because of the plastic being made of oil, the bag doesn't leak. Here is a science magic experiment that I did every time I've done it. I'm absolutely amazed. You can do it if you watch carefully. To do this, all you need is an ordinary sheet of newspaper. Take the newspaper and cut the newspaper into two long strips. Now I'm going to ask this young man right here, Ryan, you and I are going to do this experiment together. We're going to take two strips of paper. This is ordinary newspaper. Take this one, Ryan, and unfold it. One long strip, and I'm going to cut another one just like it, Ryan, about the same size. And I'm going to, we'll just push this under here. We are going to connect the two long pieces of paper end to end. So give me your end. You hold them together with your... I have made one long strip of newspaper. You saw how we did it. You can all do this at home. Ryan, I'm going to take this, and I'm going to turn this hand once, just like that. Watch again carefully. Take this hand, turn it once like this, and connect it. Ryan, hold the two pieces of paper together as you did before, and we're going to tape it again. Right here. There we go. Thank you, Ryan. Okay, you hold them together. Excellent. Now Ryan and I have one loop of paper. And I'm going to ask Ryan, because I know he's in the 3rd grade, I know that Ryan is a really good cutter. And I'm going to ask him to cut right all the way around this loop of paper. I'm going to ask him to cut it in half. Watch Ryan cut it in half, okay? And then I'm going to show you the magic. Ready? Ryan, go right there. Just cut right down the middle. Keep going. Excellent. Use those scissors. Cut right down the middle. You're doing a great job. Keep going. You're almost done because you're almost going to cut it right in half, okay? You're doing a great job. We're about 2 inches from the end. He did it. Now, think about what Ryan just did. You stand right there, Ryan. Ryan cut the loop of paper in half. then why is it, if he cut it in half, we still have one strip of paper? He cut it in half, but we only have one strip of paper. That is science magic. We call this the Mobius strip. It's really weird, and if you put one turn in the paper, you can try this and you can amaze your friends and teachers at school. And now, our next experiment is one that also baffles me to no end. It's one that I love doing because it has to do with the science of chemistry. Who can tell me, what does a chemist do? Who knows? Do you know what a chemist does?
Use chemicals,
They take chemicals and what do they do with them?
mix them.
They mix them. You will notice, of course, that I brought 3 chemicals. Chemical A,
B,
and C. They're all in flasks. What do you think I should do with those chemicals? That young lady back there, what do you think I should do?
mix them together.
I think I would. What's your name, by the way? Natalie, I'm going to take A, and I'm going to take B. Now, Natalie, do you think I should put A into B or B into A?
B into A.
You want me to put, really doesn't matter, but because you are the guest this evening, we're going to let you pick. And Natalie said B into A. Watch this carefully, don't blink. Here we go. Chemical B into A. Here's A. Here's B. Here we go. You did say B into A, right? Okay. B into A. Do you think I should be doing this? Are you sure? What do you think? Should I do that? Okay, here we go. Don't blink. Don't blink. Ta-da! And now, I'm going, Natalie, notice that I have chemical C in this flask, and I'm going to uncork it. And now, please don't ask me, Natalie, to put C into A and B because it's just not going to fit. So I'm going to start to pour. What's in here now? A and B. A and B. We're going to add it to C. Watch. Are you excited? I am. Okay, here we go. A and B into C. Wait a minute. Ta-da! Science magic. Amazing, amazing science. Well, I'm going to tell you how this works. And when you go to Wilmington High School, or maybe Wilmington Middle School, you can learn how to do this experiment. In A, before I came, when I left my lab, I put water with an invisible indicator in A that you couldn't see. In B, that was in here, that was there. In B, I put a chemical called a base, which was ammonia. And when the base, that smelly chemical ammonia, touched the water in the indicator, what color did it turn?
Purple.
Purple. And then to get it go back to clear, I added in C an acid that was vinegar. And it changed the color of the water in the indicator back to clear. Things are going to start to heat up a little bit later on here. Before it does, I have a science question to ask you. And the science question that I have to ask every single one of you is, what is it that you need to see? What do you need to see? Who knows what you need to see? Yeah,
Oh, I just forgot.
you just forgot. What do you think you need to see?
Eyes.
You need eyes. That's a good place to start. You need your eyes. And what do you think we need to see, Natalie?
Light.
You need light. We absolutely need the light. We need your eyes, light, and one more thing to see, because without it, you don't know what you're seeing.
Brain.
You're right. You saw my sign. That's okay. Brain, light, in the eye. And when you put all three together, you can see. If I take away any one of these, any one, the brain, light, or an eye, you will never be able to see. You need all three. And now, here's what's going to happen. I am going to play two tricks between your eye and your brain. And what happens in science is that your eye is connected in the back to your brain. Your eye sends messages to the brain, and the brain tells you what you are seeing. Now I'm going to fool your eye and your brain. I'm going to start out with a real simple one, and then one that's more complicated. To do the first one, take two paper plates. Put them together just like this. And then, with a pair of scissors, don't worry, this won't hurt you. I'll let you know when things are going to get dangerous, okay? You're safe for now. Here we go. I'm going to cut around the rim right here. And you'll notice that the two paper plates are stuck together. They're exactly the same size. And all I'm really interested in keeping is the outside. You can try this at home. This is another experiment you can do. I have two pieces of paper plate right here. One is in back of the other. Watch this. If I take the two pieces of paper plate and I separate them, okay, they look identical. They have to be identical because I cut them together until I do this. If I take one of them and put it on top of the other, it appears to shrink. The one on top looks much smaller. And it doesn't matter whether I put this one on top or this one on top. Every time the one goes on top, it looks smaller. Or if I flip them around this way, the one on the bottom begins to look smaller, and it doesn't matter. And you can try this at home. I am playing a trick between your eye and your brain. It's called an optical illusion. And I want you to look at my very strange looking American flag. It's a flag, of course, that's not the ordinary flag that we salute to, red, white, and blue. This one, of course, is yellow, black, and green. And I'm going to amaze you. This will be a day you will never forget. I'm going to play a trick between your eye and your brain. Here's what I want you to do. All I want you to do is stare at that one star right there. Keep staring, staring, and staring at it. Don't touch your eyes, just stare. You can blink if you need to. Just stare. And I'm going to count to 10 while you stare. Don't look at me, only the flag. Ready? 1. Keep staring. 2, 3, 4, 5, 6, 7, 8, 9, 10. Close your eyes, and now open them and look at the white part of the board. Right there.
Holy.
Wow.
Now my eyes are looking.
Did you see that?
That's the
What did you say?
I saw the American.
He saw the real red, white, and blue American flag. Andrew, I have here an ordinary styrofoam cup. Don't panic, you won't get hurt. Stand right there. Look inside. Can you tell the group, is that an ordinary styrofoam cup? Okay, is it empty? Okay, tell the group in a big voice, the styrofoam cup is empty. Tell them.
Styrofoam cup is empty.
Very good. Nicely done. Okay? I'm going to take, and we're going to go back to our little container here. Andrew, I'm going to take this pitcher of water, and I'm going to pour it into the cup, okay? The empty cup. Are you ready? Is that cup empty, Andrew? Here we go. So sorry, Andrew.
He's
All right. Give me a magic word right now.
Alakazam.
Everyone together.
Wow.
Now how he does it. He just makes it look
I have to tell you what happened. In the bottom of the cup that Andrew could not see, there was a chemical that was white powder that was only that thick on the bottom. Right now, and I didn't really mean to get you wet, that was an accident. Right now, Andrew, I want you to feel and look and hear, and what do you see? Feel. What's it feel like? Kind of. It's a gel. I'll pass this around for everyone to see. The water was absorbed by a tiny bit of powder in the bottom of the cup to make this magic trick work. I brought with me another amazing experiment. And this is something that you rarely see. I'm going to, and I'm sure most of you can figure this out. Here we go. If I take this pair of scissors and I bring it close to this, watch what happens. It's a magnet. You're all too smart for me. It's a magnet, but boys and girls, this is not an ordinary magnet. This magnet is a magnet that is the most powerful magnet in the world. And to show you just how powerful it is, I'm going to ask that gentleman back there to come on up and help me out. Your name, please?
Tom Fox.
Tom Fox. Nice to meet you. Tom, I'm going to hand you a coin. Would you take that coin and look at it carefully? And you don't wear a heart monitor or a pacemaker, right?
No.
Just checking.
Okay.
Okay.
Not yet.
No, okay. I would like you, Tom, to look at that coin and tell the group what it is.
It looks like a nickel.
It's a nickel, but it's not an American nickel, it's a Canadian nickel. And it was a nickel that was made in 1975 when they used to make nickels in Canada out of a chemical that was really nickel. It became too expensive in the United States and in Canada later on to make nickels out of the element nickel, and they used other metals. But this one, because it is pure nickel, is one of the few things that will stick to a magnet. The only things that will stick to a magnet are things that are made of iron, nickel, or cobalt. Now, Mr. Fox and I are going to show you. This is called a neodymium or dymium magnet. It is the, did I have you as a student?
I know about these.
Oh, you know that, okay. Okay. And this is the most powerful magnet in the world. It is so powerful that we're going to ask Mr. Fox to take that nickel, and I'm going to have you put your right hand up flat like this to the audience so that they can all see. And I'm going to take the nickel right here, and I'm going to place it so that I don't want anyone to think that I'm playing any crazy magic things. I'm going to just put it right there, and every time I put it there, of course, the nickel will fall right out of his hand. Stay just like that, please. And now I'm going to take the neodymium magnet, and I'm going to place the nickel right here. I'm going to put the neodymium magnet right behind Mr. Fox's hand. The invisible magnetic field is so powerful. It's going through his bones, his blood, and all the muscles in his hands, right through the thick part of his hand. And watch this. Ready? 1, 2, 3. The nickel is stuck right to the magnet through the palm of his hand. That's how powerful it is. There can be no mistakes here.
No?
Okay? I'm going to give you, Cyrus, a very special piece of paper. You'll notice on the container, Cyrus, it says,
Dangerous, dangerous.
danger. This is a piece of paper, Cyrus, that paper comes from where? Trees. This paper, though, is unlike any other piece of paper you have ever seen. This paper that came from a tree had all of the minerals that a tree sucks up when it sucks up water into the trunk and sends it to the branches and leaves. Little bits of rocks and minerals, believe it or not, that are dissolved in the water end up in the wood of the tree. So if I set a piece of paper on fire, you will see ash that is black in the end. Or if I burn a piece of wood, you see ash. That ash is the result of rocks and minerals that were in the tree, sucked up, that didn't burn. This paper had all of the rocks and minerals removed from it with a special chemical. Hold it out. Hold it out. On the count of 3, Cyrus, I'm going to, when I say drop it, you will drop it. I promise you, you won't get hurt, okay? You won't. Okay, you're getting a little nervous. That's okay. There's no reason you shouldn't be. Ready? 1, 2, 3, drop it! Isn't that unbelievable? And what was that? I didn't catch that, but that's okay.
Water?
Oh, you feel water. Well, there was no water, but you may have felt a little bit of heat just coming up from, but it completely disappeared. Here's what we're gonna do. Jose, this is huge. In the can, Jose, I need you to look. There's a cup in the bottom of the can. Tell the group there's a cup in the bottom of the can.
There's a cup.
Okay. And I'm going to take some flour powder in the bottom and place it in the bottom of that can, Jose. Just hold on here a second. Don't leave. Okay? Jose, I want you to watch and look inside and tell the audience that I just put the flour in the cup.
You put the flour in the cup.
Thank you. Okay, Jose, what I'd like you to do now is hold on to this tube over here. Just like that. Here's what I'm going to do. I'm going to take and I'm going to light a candle in the bottom of this can. When I tell Jose, he's going to blow into this tube where the soda straw is as hard as he possibly can to blow all the flour in the can up in the air so that the flame strikes it. I can't trust you guys.
Don't do it.
The candle's in the candle is in the can. I am going to put the lid on top of the can, and then we're all going to count to 3. 1, 2, 3, and Jose's going to blow as hard as he can. Let me run first, okay? Hold on. Ready? 1, 2, 3, blow! Wow! You're the man! Our next experiment involves all of you, and you need to listen carefully. Ready? All of you are going to make, all the kids are going to stand up and make one circle, starting and ending with me. Here's what we're going to do.
Other way around.
That's fine. Now, we're all holding hands, and because all of you are made up of salt water, yes, you are made up of salt water, I'm going to take a small amount. I've turned you all into one big electric wire. Don't squeeze his handshake.
I started it.
Okay. And I'm going to put a little bit of electricity through you, and you're going to feel it because we're all connected as a wire in one circuit. That's lighting the light bulb. Now, Natalie, you'll be happy to know that I'm going to disconnect the light bulb, and I'm going to hand Cyrus, it won't hurt, Cyrus, promise you. Just hold on.
Just grab it, Si.
Just grab it. Okay? And you're going to grab this one right there where the clip is. Put your thumb and finger on the clip. Okay, now, I have a wire now made up, I have a wire made of salt water, all your bodies. and all the electrons, Shane, from the generator are gonna go right through, and you'll feel a tiny tickle. Here we go.
Yes.
Hold on to that time. Did you feel it? Did you feel it? Go. Did you feel it? Did everyone feel? That's real. We've made a. Cyrus, you all right? Here we go. We've made a circuit now to prove to you. I'm going to have Shane and Jose. Everyone else, hold hands. Shane and Jose are going to drop their hands. Just Shane and Jose. Hold on to the kid next to you. Just okay. Now, Shane, Jose, right here, right here. When I say grab him, you're going to grab his hand. Okay? Now we have an incomplete circuit. I can crank away. And no one feels a thing because we have an open switch right there in the circle. Okay? Shane, you ready? Grab it! Okay, everyone sit. Go ahead. Okay. Here we go. And now, this is a science magic experiment that you will never forget for the rest of your life. This is the finale. Here we go. Here we go. I need you to sit in that chair, right on both of you. And who's the cut master?
That's a friend. Probably you.
I think she's gonna
Okay. Your name?
Let's hope so. No, just
Mrs. Ritter. Jennifer, you can do it.
I'm so in trouble for this.
You are definitely. Okay, your name?
Mrs. Poor.
Jennifer.
No.
Jennifer Ritter.
It has now changed
Okay.
to somebody else.
All right. Somebody else. You are going to help us, and I'm going to ask you to take this and hold it just like this, okay?
Oh, yeah.
Both hands underneath. You
last
don't need to
person
read
almost
what it
Oh, yeah,
says.
and this is all with the cameras on.
Okay, right underneath, okay? You all set?
No.
You want to do this?
All right, what is it?
Well, we're going back in my lab. When I left
The last person
the
survived.
Science Center, I took this bottle and I added inside the bottle,
Yeah.
I added hydrogen and oxygen gas, 2 parts,
Per million.
1 part of oxygen gas and 2 parts of hydrogen, and they're invisible gases that are in this bottle that has a little bit of water left in
I
it.
don't see it.
I'm going to bring the 2 gases and join them together. I'm going to join them together with a little bit of heat to make a new chemical called H2O, which is water.
Okay.
Okay.
Do that.
This is going to happen in
Oh,
3
thanks, Kimberly.
different stages.
Okay, let's do that.
Hold it right out like that. Step 1, come closer to me. That's it. Perfect. Step 1 will be for me to uncap it. Step 2 will be for me to add heat.
Oh, great.
Okay? Do not look anywhere but the bottom. We're going to join the hydrogen and oxygen gas. We're going to join them together and see what happens when we add heat. Natalie, don't blink.
All right, Jen.
Are you ready?
Step
No,
4,
hold on.
defibrillator.
Okay?
Just do it like
Does this thing do a pool thing?
Yeah.
Can the knees
You okay?
explode?
Yeah, I think. Yay! Explosion!
Explode!
If you don't look, you'll miss the whole thing.
Watch, watch.
No, don't drop it.
Watch the.
Wait.
You'll be okay. Get your thumb out from underneath there. There. You're all right. Trust me. I'm gonna.
It's not gonna explode.
No, I can't do that.
Yeah.
Yes, you can.
does.
You gotta do it now. It's too late. Don't go. Don't move. Don't move.
No, let somebody else do it.
Go.
Let somebody else do it. Now you let me know.
Can't do that.
Okay. That's okay.
Go, Gretchen. You wanna do it?
You gotta move quick. I don't know if I lost the gas. Whoa!
don't know.